All right, it's recording. Here we go. Exercise 1C. Let's have a look. Number properties. So we're just going back to exercise 1C to make sure that you've remembered how to do LCMs and HCFs because you will need them to do fractions. Okay? So LCM, HCF is what I'm going to show you today. Next week after your camp, because we're not going to see each other Monday, Tuesday, Wednesday. I'll see you Thursday next week. Then we'll do 1D, which shows you a shortcut to do LCM and HCF with bigger numbers. Okay, so one of the progress tasks that I gave to you in term 1, the last question, only one student out of the 2 classes that I've taught only used this particular method. Okay, and so I just want to make sure that everyone knows how that method works so that if you ever get an LCM or HCF question, for those who are planning to go Melbourne High, McGrub, sometimes those selective questions, they do require that you know this fact. Okay, so it might be helpful to know. But anyways, to start off, let's go with exercise 1C, lowest common multiple. So let's start off by understanding multiple. What does multiple mean? It means groups of or, fill this in, multiplication. So we know that multiplication, if you multiply things, it should get bigger or smaller? Bigger, very good. So you expect numbers should get bigger. So here's an example. When they ask you to find the multiples of 6, what they're just telling you is, I want you to list all the groups of 6. So you just count in terms of 6. So one group of 6 is 6. 2 groups of 6 means add another 6. That gives you 12. Add another 6, which is now 3 groups of 6. 12 plus 6 gives you what? Let's go with... Who haven't I chosen for a while now? Okay, let's go Bo. 12 plus 6. 18, very good. And then 18 plus another 6. Let's go with Will.
18 plus 24.
24. So these are multiples of 6 as we're going. 24 plus another 6. Let's go with... Was it Will? Wilbur, sorry. 30, very good. And then 30 plus another 6. That gives me? 36. And then? 42. Very good. This is what we call multiples, and you can see the numbers get larger and bigger and technically goes infinitely. Let's do the same for the multiples of 8. I did the first 3. I got 8, 16, 24. What's the next one? Let's go, Josh. 32. Next one.
40.
Next one. Oh, he's not listening. Okay, let's go. Let's go next one. 40 then. 48. Man. 56. Last one. Leon. 64. Okay, so this is really your times tables. As you can see, 8 times 1, 8 times 2, 8 times 3, 8 times 4, 5, 6, 7, 8. Okay, so if you know your times tables, that's when you can find LCMs and HCF faster. That's why fractions, the reason why a lot of students struggle with fractions is because they're times tables. Okay, the better your times table from primary school, the better it was to pick up in fractions. So it's not that you can't do fractions, it just means that if you took your time, you should take a bit longer to do. That's it. Okay? So what does lowest common multiple mean? It means now that you've got the multiples, we're looking for common. So what do they both have in common? Well, I can see that they both have a 24. Had I carried on this multiples, it would have been 42, 48, and again, we would have had another multiple, 48 and 48. But we don't want just common, we want the lowest common multiple. And therefore, the answer must be 24. Very good. So 24 is the lowest common multiple that you have. So this is the most common strategy. We list out all the multiples, and then we find the lowest common multiple. Yep.
You could multiply them together and simplify.
Yes. What do you mean by simplify?
Divide, like 6 times 8 is 48, and divide that by 6, you get 20.
Yeah. So a lot of times students do LCMs by multiplying them, but that's not always the lowest common multiple. It is for most cases, but not always. Okay. So most of the strategies most students do normally is to list the multiples. It takes a while to do, only if your times table is not strong. Now, question method answer wise, if you are strong with your multiplication tables, I don't need you to list out the multiples the way I have, but I do need that when you write the question, it's like question 1A, I do want to know what multiples you're doing. So if you did 6 and 8, then I want you to write LCM and then write the answer. So you still have a question, then you have an answer. That's if your times tables are strong. If you're getting these ones wrong, then I want you to list out the method because that's the proper way to do it. Okay? Next one. Highest common factor is the opposite of lowest common multiple. So let's break it up again. Factor. Factor means literally division, which is the opposite of multiplication. If you're dividing, is it getting bigger or smaller? Smaller. So we should expect the list of numbers shouldn't go on infinitely, like both of these lists here. It should get smaller. So when I ask you, what are the factors of 6? One of the ways to do this is you think of what numbers can be divided into 6, but I know that a lot of students aren't as strong with the division. So what I say instead is I say, can you think of any numbers that multiply to give you 6? Now, what numbers can you think of? Give me 2 numbers right now that multiply to give you 6. Which 2 numbers? 2 and 3. So those would be factors. Because if you can multiply to get you to 6, then you can divide them to get those factors. So 2 times 3, that gives you 6. Give me another 2. There's another 2. Leon. 1 and 6. And these are your factors. See how it's limited? It's smaller. It's not like multiples. Multiples can go on infinitely, but factors, there's a finite amount. And in this case, finding the pairs is usually the easiest ways to find your factors if your division is not as strong. So the stronger your multiplication tables, the easier for LCM and HCFs. Let's have a look at 8. Let's do the same thing. Another 2 different students. Let's go with Sully. What 2 numbers multiply to give you 8? 1 and 8. Very good. So 1 is a factor, 8 is a factor. Give me another 2. What's another 2 numbers? Elliot.
4 and 2.
4 and 2. So 2 times 4 will give you 8, and 1 times 8 will also give you 8. Can you see that pairing? That is what the factors are likely to end up. There's no way that you can get a factor without figuring out the second pair. There's always a pair. Okay? So now when we say, what is the common factor? Well, they both have a 1. They both have a 2. And that's about it. But we want the highest common. So out of the 2, which one is the highest common? 2. Very good. So the answer is then 2. So this is your traditional method. This is the method that all students would go through. Exercise 1D, I teach you a shorter way to do it, but it does require some extra skills to do. Okay, so at the bare minimum, these are the kind of skills that you need to develop, and that means your times tables need to be strong. Okay, let's go to, now that you know your lowest common multiple, you know your highest common factor, there are other things that will also help you, especially for exercise 1D, is you need to know squares and cubes. Now over here, I've got 6 squared. This means 6 squared. Now, a lot of students think 6 squared is 6 times 2. That is not true. 6 squared is not 6 times 2. 6 squared actually means what? Hands up if you know. Yes, Will?
6 times 6.
Good. It's timesing itself, and you should see 2 6s there. So with a square, you should see 2 6s. 6 times 6 equals what, Lucas? 36. Very good. So 6 squared is 36. Now, just like with everything that you've learned so far, if you can add, the opposite of add is subtract. If you can times, the opposite of times is divide. Then if you can square, so 6 squared gives you 36, there has to be an operation that goes backwards. What's the inverse of squaring? Square rooting. Very good. So we know that square rooting, so this symbol here, square root of 36, is actually the reverse, and it should give you the answer of 6. Now, for those who don't understand what square root means or how to work it out, for example, this one, square root of 81, it just means, can you think of a number when you times itself, it should give you 81. What number times itself to give you 81? What's the number? 9. Very good. So this is where knowing your times tables, 9 times 9 gives you 81, so that's why I know root of 81 must be 9, because essentially I'm saying 9 squared equals 81. So if I can do squaring, I can do square rooting. Okay, so they're sort of moving forward, moving back. Let's do another one. I'm going to write up a random one here. What is root of 16 equal to, can I please have, no, someone different. Let's go with Colleen. 4, very good, because 4 times 4 gives you 16. So you have to think of it as 4 squared gives you 16. Then that means backwards, square root of 16 is 4. Let's do another one. What is the root of 49? Can I please have, who haven't I chosen yet? Man, have I chosen you? Man? Root of 49. 7, because 7 squared is equal to 49. So if you can go forwards, you can go backwards. Last one. Tilly. Root of 25. 5, very good. Okay, so that's square root. What about this one now? What's the little 3 up top? This does not mean 2 times 3. That doesn't mean that. This means what, Bo?
2 times 2 times 2.
Beautiful. 2 times 2 times 2. So the cube means repeated multiplication, and you've got the 3 means that you've got 3 of those 2's there. Okay? So we can work that out. 2 times 2 times 2 is equal to what? Let's go with Liam.
2 times 2 times 2 is
8. Very good. So we can say that 2 cubed is 8. For those who don't know, 2 times 2 is 4. And then times 2 again, that gives you 8. Okay? But then if you can cube, just like we did before, if you can do 2 cubed equals 8, so moving forward, what is the operation to go backwards then? What's that called? Cube root. So before was squared, then we got square root. If we got cube, then it's called cube root. Now how do you do cube root? It looks like this. It looks like a square root, but if you put a little 3 just on top of where that little hook is, that implies that it's cube root. Cube root of 8 should equal to 2. And what cube root basically means is what number times itself will give you 8. That's what cube root means. Okay, and that's how you knew 2 times 2 times 2 equals 8. That's why cube root of 8 is 2. Now let's test. Not all of us know our cube numbers, so let's see. Anyone know what's the cube root of 27? Something times itself has to equal to 27. What's the number? Bo again. Oh, so close. 9 times 9 equals 81 already, so it's too big. I need something smaller, so it has to be smaller than 9. What is that? Yes, Liam. 3. 3 times 3 gives you 9, and then times 3 again, that gives you 27. So that's why cube root of 27 must be 3. Let's try another one. What if I gave you cube root of 64? Be careful. Cube root of 64. Think of a number times itself has to give you 64. What number do you think, Elliot? 4. 4 times 4 is 16. 16 times 4, if I write it out, is actually 64. 4 times 6 is 24. Carry the 2. 4 times 1 is 4 plus 2, 64. So cube root, oh sorry, I should have put a 3 there. Cube root of 64 is 4. Now, it's not common knowledge, but they do want you to know, in terms of mathematics, you need to know your cube numbers from 1 to 10. So what helps is if you list it out in your exercise book, just write it once, and it's always there. So if you write out 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, 6 cube, 8 cube, 7 cube, 8 cube, 9 cube, 10 cube. This will help. Now, just in case you don't know it yet, you can use a calculator, but let's see how far we can go, team. What's 1 cubed? 1. 1 times 1 times 1 is 1. 2 cubed we already know. We wrote 8 before. 3 cubed we just figured out was 27. And Elliot before figured out 4 cubed was 64. He wants to have a go. What's 5 cubed? Hands up. Yep. Good. 125. Write this down if you don't know. It's a nice list to have. So 5 cubed is 125. 6 cubed.
Is it 250?
Oh, so close. What is it? So 6 times 6 is 36, and you go times another 6. What is that? 216. Very good. Write it in. 216. Next one, 7 cubed. 7 cubed means you need to know what 7 times 7 times 7 is. So 7 times 7 is 49. 49 times 7. 300 and No, you're right. You're right.
Never mind.
7 times 9 is 63, and then 28 plus 6, yes, is 34. That's correct. 343. 8 cubed now. Let's see if we know this one. 8 times 8 is 64. 64 times an extra 8. There we go. Oh, Lucas again.
100.
No, that's okay. 3, 2. 8 times 4 is 32. 8 times 6 is 48. 48 plus 3. 8 cubed. 512. Very good. 512. Going to 9 cubed now. 9 cubed is 9 times 9 times 9. So that's 81 times 9. This should be a bit easier.
729.
Very good. 729. And last one's the easiest. Very good. Write that in. Those are useful numbers to help you calculate cube roots. See, now that you got that list, you can answer the questions below. D. Cube root of what will give you 1,000? 10, because you got the list there. So if you want 1,000 cube, that means cube root of 1,000 must be 10. What about 3 cubed? What's 3 cubed equal to? 27. So if you copy that list down, you can then answer these numbers here. You can do the same for squared if you want to as well. Square root of 36, which someone answered before, was something times itself gives you 36. Very good. And then lastly, 7 squared is not 7 times 2, it is 49, because 7 times 7 is 49. Is that pretty easy? Okay, because the next lesson, you do need to know cubes and squares so that you can do quick maths for LCM, HCF. Bo? Oh yeah, the list. Copy that list down. Very useful list for exercise 1C. 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7 cubed, 8 cubed, 9 cubed, 10 cubed. Once you're done, flip over the page, and this is your last notes for today, and then we'll start your readiness task. You will have 40 minutes. If you finish early, you write your reflection for the readiness task on Compass. Okay, flip over the page. Here's your last notes, which we'll link into next week's lesson. Prime numbers. Prime numbers. It says here, natural numbers. Anyone know what natural numbers mean? Hands up, yes. Oh, yes, it is true. It has no decimals, but something more simple. What is natural numbers? It has to be positive. And someone just said a key term. Who just said something? Something with C. Counting numbers. This is arguably the first mathematics that most civilizations started off with. So when you're doing bookkeeping or you're trading resources, the first type of mathematics that we have is called counting. Okay, so different civilizations had different number systems. We, as the world, we've worked with metric system, which means decimals or digits of 10. Right, so you got 10 digits. You got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are our digit system. But in the past, different civilizations had different numbers. They might have only had, for example, ancient Egypt didn't have the zeros. Zeros didn't come in until, I think it was India that figured that one out. So before 0, they only had 1 and 2. So then how do you count? So they called it binary numbers. For those who do systems or tech, they would understand binary numbers there. But in our case, we work with 10-digit system. So natural numbers, what they're trying to say is counting numbers. That's what you learned when you first started primary school. 1, 2, 3, 4. It's all whole numbers, no decimals, and they're all positive. Okay? Now, what is a prime number? So out of all those numbers, all those counting numbers, for it to be a prime number, it has to be divisible by 1. Okay? And a number by itself. Prime numbers must be a natural number greater than 1. Now, why does it have to be greater than 1? And the biggest misconception is a lot of students think 1 is a prime number. It is not. Why is 1 not a prime? Anyone know? Explain to me. Why? Liam?
Because there's prime numbers which have 2 that can divide it. It only has 1 which is itself.
Very good. So remember, it says it has to be 1 and itself. There are two conditions there. 1 only has factors of 1. 2, on the other hand, has a 1 and a 2. So divisible by 1 and 2 itself. 3 has 1 and 3. 4 is not, because 4 has 1, 2, and 4. See, 2 times 2 gives you 4. 1 times 4 gives you 4 as well. That is not a prime. So on the bottom there, I'm helping you to see what all the prime numbers are, because that will help you for next week's task. Okay? So that's how you know. Anyone know if it's not a prime number, what is it called? Starts with C. Composites. Very good. These are called composite numbers. So all the ones that aren't shaded, called composite. All the ones that are shaded are called prime. That's it for today's lesson. That's exercise 1C. Obviously, if you have time to do it before you go on camp, great. If you don't, it's okay. It'll be due next week, end of next week. Okay? Can you please grab out your laptop? If you've got your laptop, we're going to do your readiness task. Go to Teams.